Hello and welcome to the practical applications of Module 3, Deep Convolutional GANs. GANs mean Generative Adversarial Networks, and they are the new big thing in deep learning that are used today to do some amazing stuff. One of these things is to generate some fake images based on the vision of real images, and that's exactly what we'll do in this module. And it's part of computer vision because the GANs will have eyes through the convolutional layers to watch all these images and then train itself to reproduce some fake images. But then you have some other amazing applications of GANs that are, for example, style transfer or face swap. You can make a face swap with cycle GANs. Basically, GANs are the cutting edge models in computer vision. So I'm super excited to implement it with you in this module 3. And the good news is that this time we will implement the whole model from scratch. And this not only includes the generation of the images, that is, we're not going to take a pre-trained model like in module 2 to generate some fake images. We're going to make the whole thing from scratch. And by that I mean we're going to make a brain, we're going to create a brain which will have some eyes, and we're going to train that brain to make it smart. And by smart, I mean capable of generating some fake images based on the vision of a lot and lots of real images. These real images will get them from CFAR 10, which is a very well-known dataset containing lots and lots of images. That will be the real images on which our deep convolutional GANs will be trained, and based on its training, it will then be smart enough to generate some fake images. And you're going to see that fake images. I'm not talking about some random gradients of colors. It really looks like something real. So you'll see that in the end. We will see that in the final tutorial of this module, as usual. And now, if you're ready, we're going to start implementing this model from scratch, the deep convolutional GANs. So the first thing we're going to do is open Anaconda, because I want to make sure you don't forget to connect to the virtual platform. There we go. So you go to Applications on Virtual Platform, and right after it's loaded, you click on Launch here to launch the Spider IDE. All right, Spider is coming, and here is Spider. Okay, so now we have to set the right folder as working directory. So we're going to go to File Explorer. We're going to go to where your Computer Vision A to Z folder. It is on my desktop. We go inside the Computer Vision A to Z folder, and now I have to say, congratulations, you reached module 3. This is going to be a big module. We're going to implement a real, huge, powerful computer vision model from scratch, including the training. So let's do this. Let's go inside module 3. And as for module 1 and 2, you have two codes. The DC GAN commented. We're going to look at that right now, by the way, because I really want you to get the structure of the code. And we have our implementation that we'll do ourselves. It contains more than 100 lines of code. So that's quite a challenge, but we'll make it. But before we make it, I would like to, as I just said, show you the structure of the code. So that's the code. All the lines of the code are commented, and you can have a clear global view of the structure. It's important sometimes to take a step back and visualize the structure. So that's exactly what we're going to do now. So we start by importing all the libraries. So that's almost the same as before, except that this time we're going to use Torch Vision to visualize the images. Then we set the values of some hyperparameters like the batch size, the image size, that is, we set the size of the generated images to 64 by 64. Then we create some transformations. Exactly like in module 2, we'll use some transformations to make the input images compatible with the neural network of the generator. Prepare yourself. This time we're going to have two neural networks. We're going to have the neural network of the generator and the neural network of the discriminator. So that's going to be something, but these transformations are for the generator. Then we load the dataset from this folder here, data that contains the CFAR 10 dataset in batches. So we just load the dataset from this folder. As you can see here, root, we take this data folder, and then we use Torch utils data loader to get the images of the dataset batch by batch. Indeed, as you can see, we specify here the batch size, to specify the size of the batch. And then we use this shuffle equals true here just so that we can get the images in a random order. All right, and then num workers equals true means that we're going to have two parallel threads that will load the data. And using the data loader with this shuffle and two threads allows us in fact to get the data faster, much faster, when the datasets are huge, which is the case for our CIFAR10 dataset. All right, then we define the weight init function that will take as input a neural network and that will initialize all the weights of the neural network. So we will apply the weights init function to both the neural networks, that is the neural network of the generator and the neural network of the discriminator, to initialize all their weights the right way for the adversarial networks. And then here comes the structure I really want to highlight and that I really want you to have a clear understanding. That's super important before we tackle this. So the first thing we're going to do is defining the generator. And we are going to define it through a class. That's the best way to define a neural network. So we will define the architecture of the neural network in this first class J, which will contain this architecture and the forward function that will propagate the signal inside this neural network. Then once we define our generator with this class, we'll be able to create the generator itself, which will be an object of the G class. So that's a first important section of the structure of the code. Then once we're done with the generator, we'll take care of the discriminator, and same, we'll define the architecture of the discriminator with this class D, which will contain the architecture itself, and same, the forward function that will propagate the signal inside the neural network of the discriminator. Then once we define all this, we'll be able to create the discriminator itself by creating an object of this previous class, the D class. And then that will be a huge step done because we will have created the brain of our computer vision model. Because the brain is composed of the generator and the discriminator. But then we will just have a brain that is not trained yet, so our DC GANs will still be stupid, and therefore we will need to train it. And that's exactly the last section of the code where we will train the DC GANs by training two brains at the same time. You know, we have this big brain of the DC GAN that is composed of two brains, the brain that is the neural network of the generator, and the other brain, the neural network of the discriminator. So we will train these two brains at the same time according to the process that you saw with Kirill in the intuition lectures. That is, you know, we first train the generator with a real image of the dataset, then we train the discriminator with a fake image generated before by the generator. That's the first sub-step of this big step here. And then the second sub-step is to update the weights of the neural network of the generator. So we will see that in details, great details actually. We will code each of these lines of code by explaining what's going on. And eventually, after we're done with the implementation of this section, not only will we have brains, but also these brains will be smart enough to generate some images. And since they'll be smart enough, well, of course, we'll make them generate some fake images, and we'll see these fake images in the last tutorial. So I can't wait to start. I'm super excited to code all this with you. I'm gonna close this now, and here we are back in our non-commented version of the code. That is the code where we'll implement the whole model. I already prepared the first sections here where we import the libraries, set the hyperparameters, create the transformations, load the dataset, and define the weights init function so that we can directly dive in to the implementation of our future smart brains. So let's do this. I'm getting back into my repo, data. Oh, and by the way, this last folder here, results, is an empty folder so far, but that will exactly be the folder that will be populated with the fake images of our DC GANs. So here we go. Let's tackle our deep convolutional GANs and let's start in the next tutorial. Until then, enjoy computer vision.